scenarios. The first one was just water flowing down your stream table at a rate you chose. Then you used more water, then less water. You had a flooding situation. You had flooding with artificial controls, maybe like a dam or something that you built in. You had then a trench or a river that had sweeping curves. And then you increased the slope of your stream table and modeled that. Okay, first, what were the limitations of this model? What were the limitations of this model, Elizabeth?
The limitations of this model was the use of the spray bottle, whether you can control the mist or maybe you want it indirect, but it wasn't precise as well.
So you mean like the way the water was applied to the stream table? Okay, thank you. Anything else? Kim?
The size, it was harder to visualize small changes because of the small amount of sand versus in a big stream table. I thought it was a little easier to see.
Okay, so the size of the stream table was a little bit short.
A little confining.
Okay, all right. What else? Candace?
The substrate or the substance we use was sand. And that's not always the case in real life. There
Okay,
are different types of rocks.
very good. So Candace was saying that the material we used was sand, whereas that's not always the case out in the world, in nature. Tim?
The amount of sand that you use.
The amount of sand that we used, good. Anything else? Yes, Tanya?
There were no ground cover, so
There was
we had
no
a lot of
ground So how would ground cover affect your stream table? Or the-
But I think some of it would stay,
What would stay?
some of the sand would have stayed in place had we had some sort of, something to imitate ground cover.
Okay, good, thank you. Toby?
To simulate ground cover, you can use bottle caps.
Okay.
It'd be like rock.
Cover the ground, yeah, okay, good. That's a great idea. Okay, so how does erosion and deposition vary in each of these stream conditions? Somebody give me a comparison of how erosion and deposition vary. Now, erosion is the moving of the sediments, deposition is putting them down. So how did erosion and deposition vary in these? Elizabeth?
Erosion varies upon the increase of the amount of force of water flow.
So it's,
And-
what do you mean by that?
That if the water was flowing faster, then the particles may be more likely to be carried away faster.
What makes the water flow faster?
The force of gravity pulling down
Okay,
the water.
that can affect it. Was there, so which two simulations are you thinking in your mind you're comparing?
The flooding, I guess.
Okay, so like normal conditions, the first one, your initial trial versus your flooding. So which scenario, the normal conditions or the flooding, yielded more erosion in your stream table?
More erosion occurred with flooding because of the force of the water weathering and then eroding the particles of sand and gravel.
Okay, so what about deposition? Did you notice any difference with the deposition?
The deposition of the particles, whether they were deposited, I don't know, is it compiled more in an area
Okay,
versus spreading out by just a trickle of water.
okay, so in the normal conditions, it spread it, the sediment spread out and were deposited in a more even
More
way?
even, yes.
Okay, whereas when the flooding occurred, you had increased erosion and all of that sediment was deposited in one area rather than spread out.
Yes.
Okay,
According to ours. I mean, it might not always, but it was either a limitation or just our results.
okay, I'm getting some head nodding and thumbs up that other people saw those similar results. That's great, thank you. Okay, when the water flowed down the stream, what did you observe about the water flowing down the stream?
At first, well, after we actually decided to flow the water, it was restricted to, well, first it got saturated at the very, very top. It built up, you
What
know,
is, what
what am I talking about? The water.
the water
Saturated the sand.
The water saturated
And
the
then
sand.
once the sand at the top of our model, it started diverting to the valley, or the valley that we made, and was restricted to that area. But it also started, I observed that the water started to go down, like move the sand out of the way as it pushed towards the base of the model. It eroded
Very good.
the sand.
Okay, good, thank you.
These
So-
were quick ad, looks like,
Did the shape of your river change any?
yes.
Okay, what happened to the shape of your river?
Ours
Or your
got,
river valley?
our river valley got wider, but as we started moving the cone and moving the placement of the water, my picture's very horrible, but we got more valleys.
Okay,
It started making one larger valley and then it got skinnier towards the base, but it still was pushing, just making it bigger.
it was getting wider.
It was making the valley wider.
So if
But
our
really-
stream table were much, much, much deeper, what do you think would happen to the shape of that river valley? You said it got wider, but if our stream table were 3 feet deep, what would happen to that stream?
It gets more narrow towards the base, or as it gets to the ground, or
It would start to become deeper. Instead of just keeping getting wider, because it had nowhere else to go, really. So that's why it started getting wider, whereas if it was a bigger model, then it would start getting deeper and still widening both ways.
Okay, very nice, thank you. So what happens whenever that water comes down your river valley and then your stream slowed down once it got to the bottom and it wasn't at such an angle, hit the bottom, what happened then? When your stream slowed down, what happened? What did you observe? When your stream slows down, so the water, the energy is decreasing in the water, what happens? Ashley,
You have more deposition.
you have more deposition. And is that what you observed? Where did your sand end up? Your sand was deposited, Elizabeth, you had a comparison a minute ago that whenever on your initial trial, your water went down and then it hit the bottom and it spread out, right? So whenever your water hit the bottom, that energy immediately decreased and the sand came out of the water and deposited. What happened whenever you flooded it and the sand didn't spread out evenly at the bottom? It made a pile in the corner, right?
Created a delta, is that what you call it?
No, I'm not assigning any landforms, but why didn't it just immediately drop out at the bottom? Why wasn't this sand in your flooding stage, why wasn't this sand deposited at the bottom like it was in the initial trial?
There may have been some larger particles that prevented these sand particles from continuing to flow out, and it collected in the area, so everything that came down started compiling on top of that.
Okay, so if you have, on your back porch, let's say there's a bunch of dirt on your back porch. I have animals and there's always dirt in the back porch. So if I get a water hose and I just let the water hose flow, you know, it's on high, so I'm getting a good stream, and I put it on the dirt, that dirt is going to move a little bit, and then as the water spreads out, then the dirt will set back down. Okay, so that's erosion and deposition. Now if I increase the volume of water in my water hose, and I put my thumb on it to make it spray and increase the force, my water will still spray the dirt off of the patio, but it will take a longer distance for that water to slow down enough and lose enough energy so that it's not carrying the sediments anymore. So the more energy the water carries, the farther those sediments are going to be carried with it. Okay? The last, no. Here we go. Oh, no, let's look at this. What is the order in which the particles dropped out? If you looked at your sand, this sand did not have all the same type of particles. There were pebbles in there were tiny pebbles, there were sand particles, there were a whole bunch of different sizes. So if the stream table were longer and we could observe this more carefully, what do you think the order would be that these particles would start dropping out of the water? As the water carried it, which particles were going to drop out first? Toby?
Very fine, like silt. Dr. West came by and said, hey, y'all looks like Venus. Which told me that depending on where you got your sand out of the container, silt was at different levels. So when you use your stream table, the silt went to the container inside your little container, your
Bucket?
kitchen container.
So what does that mean?
That was much lighter or easier to move as compared to the other sediments. I was going to let other people answer some of the other.
So you're saying that the water in your bucket is what that muddy looking water, the silt, is what was not deposited in your stream table?
It didn't stay there.
So it wasn't deposited
Right.
on the bottom of your
Right.
stream table. So what was left in your stream table?
Sand,
Sand and
gravel.
gravel. Okay, so the heavier particles were deposited while the lighter particles went on into your bucket.
Yeah.
Okay. Elizabeth, did you want to share something?
I was just gonna include that the least dense particles were the ones that were, the sand particles that were carried away faster than the rocks, which were more dense.
Okay. Let me ask you some questions about that. Does the density of an object have anything to do with the size of an object?
No. Good.
No, it does. You're right. No, it doesn't. So what is a better word we can use in this scenario than density?
Okay.
What? Can I?
Go ahead.
The,
From a friend?
Yes.
the
Okay.
more massive,
No.
like the mass, the higher the mass, the gets deposited first.
Okay. So, for example, if there were marshmallows in our stream table,
Big.
and they're bigger than everything, but their mass is very low. They have a tiny mass. So if we rained on our stream table, what would the marshmallows do? They would be washed away too. And if they could fit down the tube, would they end up in the bucket with the silt? Yes. So they're very low density, but they also are big. So it's a matter of their mass. So the more mass that the object has, the more it's going to take more energy to move it. Okay? So, and Craig brought up a great use for this stream table. Craig, you want to share this?
Okay. Okay, well, in biology, biology, ninth grade, we have to deal with creating algae blooms, or eutrophication is what it's called, and algae blooms suck the oxygen out of the water, and kills fish. I don't know if it sucks it out. The oxygen reduces the oxygen in the water, and you get a lot of fish dying, right? So that comes from fertilizer in the farmland. So I said I can use this in my class because Greg added that I can put green fertilizer on top and grow.
Like Miracle Grow, it comes in a little package, green and granules, you dissolve it in the water.
Yeah, and then you can see the greenish dye, I guess, at the bottom where the water is. And that can show the runoff from the fertilizer going into the ocean or lakes. And then that would be where the algae bloom would form. I don't know if they do that in life science for 8th grade, like at all. You know, 7th grade.
No, we do it in 8th grade too.
Yeah.
Effects on human impact on
Yeah.
ocean systems.
Yeah, so you can maybe tie it in that way.
Yeah,
I've done that with Kool-Aid.
thank you for sharing that. Okay, so let's do some quick questions, okay? So everybody turn around here, this is not on your handout. Okay, this is not the slide. Here we go.
I like real.
Okay. This is just kind of a overall view here. So if two identical rocks were weathered, one weathered mechanically and one weathered chemically, how does the debris for each rock differ? Or the result? Chemical weathering versus physical weathering or mechanical weathering. What is the, Brenda, you got it? You want to share the difference?
If it's physical weathering, then the debris is the same chemical makeup. So either it's the same rock but smaller sizes, or it's the minerals separated out that made that rock. Whereas if it's chemical weathering, it's a different composition, it's been changed.
Okay.
So it's not the same rock in different sizes, or it's not the same minerals that made up the rock.
Okay. Okay, good. Thank you.
I have a question.
Yes.
Would that, on that, would the chemical weathering cause more crystallization, would it cause crystallization?
The weathering does not cause
I'm talking about
crystallization.
chemical.
Yeah,
weathering.
chemical
Not-
weathering does not cause crystallization. That's a evaporation.
Well, that's what I mean. Eventually, that's going to, the water's not going to be there.
It could be.
Well, it could, but
I mean, if the water evaporated at some point,
Yeah.
that could
create.
something be deposited or crystallized from that, precipitated out. Okay, how does mechanical weathering add to the effectiveness of chemical weathering? So let's say you take that granite and you physically weather it up into crushed granite. How will that lead to the effectiveness of chemical weathering? Just a second. How does mechanical weathering help or hinder chemical weathering? Brandon?
I'll try it based on the example with the sugar. It, like you said, it can decrease the surface area of it, and it makes the
I'm sorry, what decreases the
okay.
surface area?
the